Hello everyone. So in this tutorial we're going to build event parity generator in our Proteus simulation software. Alright, so this is the circuit diagram and we're gonna start building it right now. So as we see in this circuit, we'll be needing some XOR gates and some inputs and outputs. So let's just go to our Proteus simulation software and we're gonna select those. So we need XOR gates. So we're gonna go to select simulator primitives and we're gonna select XOR gates. Then we need some inputs, so we want to select logic state. Alright, we can also take switches, but I'm gonna do the example using logic state. So we also need some LEDs so that we can check the output. Sorry, so I'm gonna take the LED blue light. Alright, so that's it. So now I'm gonna build the diagram. So the diagram is quite simple. So two XOR gates and there is another XOR gate and there will be an LED at the output. There will be a ground so that the LED can be connected to the ground, and there will be inputs. So the inputs will be given as logic states. Alright, so there are two XOR gates, so four different inputs. So now I'm just gonna connect them together. So I'm connecting them based upon the circuit diagram I just showed a few moments ago. So you can actually rewind the video and check that out again if you want. And here I have connected the whole circuit. So now this is an event parity generator. Alright, so we wanted to build an event parity generator and we have just built it, an event parity generator. So now we want to check the output for this event parity generator. Alright, so since this is an event parity generator, so if I give an input which has even number of ones in it, then the output will produce 0. If I give an input which has odd number of ones in it, then the output will give 1. So let's see whether it does the same or not. So if I run my circuit now, the simulation is here. So right now there is actually no 1 in the input. All the inputs are actually 0. So since there is 0 number of ones and 0 is counted as even number in this case, so that's why the output is producing 0, because the number of ones in the input is already even. Alright, so now if I change just one input here, just one input, so you can see among the four different inputs, only among the four different inputs, 3 of them are 0 and the other is 1. Alright, so the number of 1 in our input is actually 1 now. So 1 is an odd number. So to make it even, the output will produce the bit 1. Alright, so the LED is working, that means the output is giving the value of 1. So if I change another input bit from 0 to 1, so right now the input has even number of ones, that's why the output is producing 0. And if I change another input bit, so right now the input has odd number of ones, so the output is producing 1 to make it even. Alright, so at any given moment, if we consider the input and output together, so at any given moment the total number of ones should be even in case of even parity. That's why when we're putting all the ones here, all the input values are 1, so 4 ones, and it is an even number, so it is already an even number, so there's no need to give another 1 at the output. That's why the output is not working, so the output is producing 0. But if there are 3 ones, so the input has 3 different ones, so the input has even number of ones, that's why to make it even, the output is giving 1, so that the total number of ones in this circuit are actually even. Alright, so this is how event parity works.